Hi everyone. Here we'll be starting with the type 2 questions of, and the first thing is this is not exactly type 2 question, but I'll try to convert it into type 2 so that we can have a smooth transitioning between type 1 and type 2. Okay, now let's directly see what the question says. So here you are given number like few points. Let's say n equals to 5 in numbers, and what you want to build a staircase with these coins. And what does it mean? It means that for every ith row, let's say first row, second row, third row, first row would have one coin. Let's say because you are having 5 coins, so now you are remaining with four. Second row would be having 2 coins, third would be having three, fourth would be having four, and they will be having only when you are remaining with that much of coin. So when your first row is done, you are remaining with four. You are remaining with four. And when your second row is done, you are remaining with one plus two, three. You are remaining with 2 coins. And finally, you should be putting 3 coins, but you are remaining with two only. So you put two here. Okay. So whatever I have to tell, and see, this is complete row because whatever you can put, you have put. Whatever you can put, you have put. Here you can put three, but you are left with only two. So this is not complete. So you have to return the complete number of complete rows. That's it. In this question, it asks you have to return complete rows. Now, if you see how that rows are increasing in this order: 1, 2, 3, 4, 5, 6, so and so. Okay, and here let's see in simplest way, in brute force, what we can do. You are given n equals to 5, n equals to 5. Okay, and you want to find number of complete rows. You can see here, guys, what we did. Let's say in the first row we kept one, in second row we kept 2 coins. How much coins we kept? 3 coins we kept. Okay, 3 is lesser than 7. So because, sorry, 5, not 7, we were having total 5. So 3 is lesser than 5 up till here, and you get the sum of these first two rows. You got the sum, and it is lesser than 5, which means that, yeah, these two rows you can fill. Then you went on for this third row. You saw that when you add plus 3 to that, 3, 1 plus 2, first row is complete, second row is complete because you are having enough of the coins. When you added to the third row's coin, because in third row you have to put 3 coins, and when you added that, the result became what? 6. But you have only 5 coins. So you see, guys, what we are doing. Let's see, consider them as staircases, possible staircases. The first staircase, second one, third one, fourth one, and in this way. In brute force, what you can do is start from this one index, sorry, this one value, and start adding the subsequents. And till what point? Till the point where you are what you are getting values lesser than this thing, lesser than your this value, the target value, which is n equals to 5. So you have to keep on adding till then. So what you have to do, and let us prepare a count variable, or you can also use that I variable in loop, but let's keep a count variable. So what you can do, if your let's say you added what, no, you not added it right now. Let's keep that sum variable here, sum equals to 0. So if sum plus I is lesser than equals to what, n is lesser than equals to n, you will do count plus plus, and also sum plus equals to I. Okay, or you can here write sum equals to sum plus I. No problem, it is just a shorthand operator. You can also write like this: sum is equals to sum plus I. So this thing is clear, I hope, guys. So till the point it is lesser than, the sum is lesser than equals to 7, you will increase, you will say that, yeah, my number of rows, my number of complete rows, their count will keep on increasing. So here 1, obviously initially your sum variable was 0, you added plus 1 to it, so your count also, and let's keep a count variable. So you because 0 plus 1, its sum is lesser than n, which was your 5. You added a count variable, you incremented a count variable from 0 to 1. Okay, then you added 2 to it, now sum became 3. Now your sum became, initial it was 1, it became 3. 3 is lesser than 5, you had incremented count to 2. Now 3, you got this 3. So 3 is 3 plus this sum, which is 6. Now 6 is obviously lesser than what, sorry, it is greater than what, this 5. So from this onward, you will not be adding that to your sum variable, and in that way you will not be incrementing this count, because you know this is the maximum count you can have. because you exhausted your what coins limit. So you see in linear traversal, in or like what brute force, what you saw here, first thing is you are going in linear direction order of n, and the second is it is sorted at the same time. This is the hint, first hint. And you also got to know about what, you also got to know about the division of your this entire space. You know what what you got till the point the sum of these first n numbers, first k numbers, let's consider this k, first k numbers, first k numbers, their sum is lesser than equals to n. Here your answer lies, and obviously here your answer lies, which you can call it favorable zone. Let me write here in the next page. So guys, see this carefully. So till the point sum of first k numbers, first k numbers, sum of first k number is lesser than what, n, is lesser than n here, because here you were iterating, here you keep on iterating, 1 plus 2, it's sum of lesser than, then you got 3. Okay, so what I'm saying is we can call this favorable zone, we can call this favorable zone. And the second is, other one is greater than who sum, like from the point where sum is greater than n, you start calling them unfavorable. So what does this mean? When you are having 1 2 3 4 5, and because if the n is, if n value is 5, so obviously number of staircases, if you just think of it, number of staircases cannot go more than 5, cannot go more than 5. Are you getting it or not? Because at every staircase at least you are using one coin, like it should be more than one, because at first you will be using one coin, then two coin, then three coin. But even if you keep one coins at a time, even if you keep one coins at a time, the number of staircases will be at the max 5. Obviously you can reduce this to n by 2 as your upper limit, it is your task, think of it, but I'm keeping it n equals to 5, let's say. Sorry, h equals to 5 right now. So l you will be starting from here, h will be starting from your n value. Okay, the final n value. Now what you got? So what I say, sum of first n values, sum of first k values. You don't know k value obviously, but you know that, just think it in this terms, that till the point your sum is lesser than n, which was your 5, n was your 5, till the point your sum is lesser than n. And what is that point? Only do these two favorables, and they are considered favorables. And when your sum started going greater than this n value, greater than or equal to, sorry, not equal to, greater than only, so lesser than equal to it is favorable, and greater than it is unfavorable, greater than n it is unfavorable. So this is unfavorable. Now guys, what you want, what you want, the last favorable value you want. Again, the question comes down to the fact that you want what, last favorable value, that is it. Now this favorable value, you know, as I told in part 2 video, this is the last element of first space. At termination of binary search, who will give that? Obviously when binary search was about to end, l will be here, h will be here, h will be here. Okay, so if you had started from I equals to 1, sorry, l equals to 1, l equals to 1, and h equals to 5, so when your binary search was about to end, when you are doing binary search on this sort of space, who will give your answer? H will return your answer, that yeah, 2 is the number of complete rows that you can make. And how you got this? You know, we did sum of first and natural first k numbers whose sum is lesser than equals to k. This is number line, this number line depends on that. Okay, now let's see one more thing, and I'll just quickly cover when I finish this. Now the binary search thing are clear, but how would you, like as I said, this is this is going to be type 2 question. So in that f block we will write some function, although it is not that needed, but we'll start writing the functions right away. We need some function to decide whether it is favorable, because because you said that this is favorable only when the sum is lesser than equals to n. So what I say, let's see for sum of first natural numbers, sum of first two natural numbers, because you will obviously start from this. So what is the sum of first two natural numbers? Let's say if it is value l, so it is value, let's say what we can take, we can take, let's say, k value. So sum of first k natural number is k into, I think k minus 1, or what is this? Wait, I'll written a formula, I forgot it. K plus 1, sorry. So k is equals to k plus 1 divided by 2. So this is how you calculate the sum of first k natural numbers. So you know Sum of first n natural numbers, so sum of first k natural numbers whose value is lesser than n, you'll call them favorable. Now see this. Let's go for this 4. Now sum of first 4 natural numbers. Let's see if it is lesser than equal to n or greater than n. So sum of first 4 natural numbers. 4 into 4 plus 1, which is 5 by 2. So 2 to cancel, sorry, 2 cancel 10. Now 10 is what? 10 is greater than 5. And this is on this basis, you said that this would be an unfavorable. And same goes for 3, because for 3 natural for first 3 natural number, the sum is 6, which is obviously greater than 5. So this is the final favorable range, this is the final unfavorable range. And how you decided this time? You will be writing a function in which, if you get, let's say, because obviously you will be using mid values. Let's say your mid is at 3, your mid is at 4, or your mid is at 2. So when in if condition, you have to write some function, and what that function will be, that will be checking if that sum till mid value is what, lesser than equals to n, then that if condition will be true. Otherwise, and it will be favorable, and otherwise it will be unfavorable. Now let's see what I write as a solution, and I'll explain. No problem, guys. So as I said, keep the binary search as clear as possible. Okay, keep the binary search as clear as possible. So you got this ans here, you see, so I started with an ans variable, but I never used it anywhere. So avoid using this. I wrote it just to like let you know, guys. L and h can be maximum n. The h limit can be maximum to n, not more than that. L will be obviously starting from 0, or you can keep it 1 as well. Nothing to worry, because the constraint is, I think, greater than 1, number of points n. So this while loop, I have kept it as clear as possible. Okay, just calculated a mid. This is your favorable zone. If this is your unfavorable zone. So how, when you decide this is favorable, you will see is good, that is this number is good or not. So what I mean by is good here, that will the sum of these first mid values, because obviously you got this mid somewhere, let's say you got this mid here. So you want to check that the sum till this 4, starting from obviously this one, the sum till this 4, whether it is greater than n value or lesser than n. That is why you are having n. So what you did, you saw this mid into mid plus 1 divide by 2. If its sum is lesser than equals to 7, you say that yeah, this particular 2, this my sum up to this, my sum is lesser than equals to n. So this thing is also in favorable zone. Okay, so this is how you will decide this favorable and unfavorable this time. As I said in my earlier video, I hope in part 2 video, that, and when in questions you see the favorable and unfavorable, you decide directly by seeing by naked eyes. Here you cannot decide that directly. Here the favorable and unfavorable will depend on their sum, whether their sum is lesser than or equal to that n value or greater than. So that's it, guys. So this is what my intuition, my approach about this problem is. I hope you like that, and do let me know in comments if something I missed. Thank you.